In section 8.4, we turn our attention to scientific notation. You might have seen this before, hopefully you have. If you haven't, here we go. The idea behind scientific notation is that we're going to be working with powers of 10. And we need to follow this form where we have some constant times 10 to a power. This is one case, one of the few cases where it's okay to use x to show multiplication. One of the qualifications we have is that that coefficient has to be at least 1 but less than 10, and that means we need to get the decimal in the right place. And then n, our exponent for 10, will be an integer. Could be positive, could be negative, could be 0, but it will be an integer. So we're going to go ahead and look at some examples here, and I'll let you read through this part. But the idea here is that we're starting with a number that's in standard form, standard notation, the way you would typically see it. We're going to convert it to scientific notation. So the decimal has to go after the first number that is not a 0. 4.57, we don't need those zeros because those are placeholders. Times 10, and then to figure out where what our exponent will be, look at where the decimal is in scientific notation and move it to where it is in standard form. 1, 2, 3. We have to go 4 places to the right to get to standard form, so our exponent here is 4. In the second case, we still have our first non-zero number is 4, so we put the decimal after the 4, and we still get 4.57. But now we look at where the decimal is in scientific notation, and we have to go to the left to get to standard form. We go 1, 2, 3, 4, 5 places to the left, so we have negative 5 as an exponent. Notice in both cases we get a coefficient that's at least 1, but less than 10. Also notice, if you look at the absolute value of this negative exponent, that would be 5, subtract 1, and that's 4. That's the number of zeros that you'll have after the decimal, but before your first non-zero number. Now going from scientific notation to standard form is even a little simpler. We just move our decimal the number of places and the direction indicated by our exponent. So we start with 3.85, and the exponent of a positive 6 tells us to move the decimal 6 places to the right, and notice that we need to fill in some zeros as placeholders. So we end up getting, if we put commas in to make it more readable, 3,850,000. Okay, and same idea here. We have 3.85, but because the exponent is negative, we need to move to the left. So it's a negative 6 means we're going to end up with 5 zeros. Let's see if that holds true. 1, 2, 3, 4, 5, 6 places to the left, and we need 1, 2, 3, 4, 5 zeros to fill in as placeholders. So it took one move to get past that first non-zero digit, and the rest of the places all need zeros as placeholders. So we have 0.00000385. Now can you see why we like to use scientific notation sometimes? This is a lot nicer to write than having to write a whole bunch of zeros. This even more so. Who likes to write a decimal with a whole bunch of zeros where we don't use commas to make it easy to read? Alright, now what about if you have to multiply or divide numbers that are in scientific notation? Well, look at the coefficients first, then look at your powers of 10, and use those rules of exponents that we've been working with. So here we have for our coefficient 3 times 1.5, and then for our power of 10, because we're multiplying, we add the powers. So 8 plus negative 3. So our coefficient 3 times 1.5 gives us 4.5, and then for our exponent 8 plus negative 3 is a positive 5. We already have an answer, a coefficient here that's at least 1 but less than 10, so we're in good shape. Here we have a quotient, so we have 4 over 8 for our coefficient, and then to get our power of 10 we need to subtract, so 5 minus negative 4 will be our exponent. Okay, 4 over 8 is the same thing as 1/2 or 0.5. Okay, in the past we've preferred, or at least I prefer to work with fractions, but scientific notation we want to work with decimals. Some of you will like that. Okay, so we have 0.5 times 10 to the 9th power. 5 minus negative 4 is a positive 9. But now notice our coefficient is less than 1. So we need to move the decimal. We need to move it 1 to the right so that we get the decimal after our digit. And we counteract that by subtracting 1. So when we move the decimal 1 to the right, we're essentially multiplying by 10. We counteract that by dividing by 10, or in other words, multiplying by 10 one fewer times than we originally were going to do. And so we end up with, instead of 0.5, 5 times 10 to the not 9 but 8th power. Okay, so, here are some examples of where we use scientific notation. Notice that we're going to use this typically with either very large or very small numbers. So we don't have to write all those zeros, and we can get an idea from a very quick glance at how large these numbers are relative to one another. So here's Avogadro's number, 6.022 times 10 to the 23rd. Certainly you'll run across that number in chemistry. This is the number of atoms in a mole. This is also the number of atoms of hydrogen it would take just to weigh 1 gram, if that gives you an idea of how small hydrogen atoms are. And speaking of how small atoms are, if you look at carbon atoms in diamonds, so in its pure form, the approximate distance between those atoms will be 1.54 times 10 to the negative 10th meters. So really, how big is this number? I don't know. It's really inconceivable. I can't even imagine that number. It's so big. And this number is so tiny, I can't even imagine it. And then, by the way, the unit 10 to the negative 10th meters is also called an angstrom, because that's a very common unit of measurement in molecular distances. All right, let's look at some more examples. So we have a number in standard form, and we're asked to convert it to scientific notation. So we're going to put the decimal after the first number that's not a zero, so 5.48. We don't need the remaining zeros. Those are just placeholders. Times 10, and then let's see, our decimal in scientific notation goes here. To get it to standard form, we have to go 1, 2, 3, 4, 5, 6 places, so our exponent is 6. Here we have a number that's almost in scientific notation. We really only have to move that decimal 1 place to the right, but that means we need to subtract 1 from our exponent. So we counteract the increase in the number by decreasing our exponent. So this is going to be 5.74 times 10 to the 7th. Okay, number 3, write 9.54 times 10 to the negative 7th in standard notation. And if you caught what I was trying to get across before, 10 to the negative 7th is going to have 6 zeros after the decimal, but before the first non-zero number. So 1, 2, 3, 4, 5, 6, and then our significant digits here of 9, 5, 4. And if you were to check that, if we start with a decimal here and go 7 to the left, 1, 2, 3, 4, 5, 6, 7. We end up where we're supposed to be. All right, here we're going to multiply two numbers that are in scientific notation. So let's take 8.4 times 3.2. This will give us our coefficient. And then because we're multiplying, we add our exponents. 5 plus negative 5. So this will give us, let's see, if we take 8.4 times 3.2, I've got a little calculator on the side here, that's going to give us 26.88 times 10 to the 5 plus negative 5 is 0. But we're not done yet because that coefficient is too large. We need to move our decimal 1 to the left here to get that coefficient less than 10. That means we need to counteract that by adding 1. So when you move the decimal to the right, counteract it by subtracting. Move it to the left, counteract by adding. So this is going to give us 2.688 times 10 to the first. Okay, number 5, here we have a quotient. So we're going to look at 8.4 divided by 3.2. And then for our exponent, we subtract. So 5 minus negative 5. Okay, so if we take 8.4 divided by 3.2, that will give us 2.625. 2.625 times 10 to the 5 minus negative 5 is 10. We look at our coefficient, we find out, aha, we're in luck because this is already at least 1 but less than 10. So our decimal's in the proper place and we're done. Okay, number 6. Simplify negative 3 times 10 to the 4th, all raised to the 3rd power. So we need to, first of all, apply that exponent to our coefficient and then use the power of powers property for our exponents. So 4 times 3, those are both exponents or powers, we multiply those together. Negative 3 to the 3rd power is negative 27. Okay, negative 3 times negative 3 is a positive 9, times negative 3 again is negative 27, times 10 to the 12th. But of course we need to move our decimal, and this is going to happen very often when we're working with multiplying or dividing numbers in scientific notation or raising them to a power. So ignore the negative for a moment and focus on the 27. We need to move that decimal 1 to the left here, which means we need to add 1 to counteract that in our exponent. So this is going to give us negative 2.7 times 10 to the 13th. Alright, number 7, our last example. Simplify 2.4 times 10 to the negative 4th, all raised to the negative 5th power. So now we're taking a scientific, a number in scientific notation, raising it to a negative exponent. So we can focus on our coefficient here first. So this is 2.4 to the negative 5th power times 10 to the negative 4 times negative 5 power. Remember, power of powers property, we multiply those exponents. So this we could write as 1 over 2.4 to the 5th power times 10 to the positive 20th power. And now we want to figure out what is 1 over 2.4 to the 5th. So I'm going to punch in 1 divided by, parentheses, 2.4 caret 5 to raise it to the 5th power, close parentheses, and we get 0.012. I'm going to round this after that second 5, so 4 significant digits should work for us. So we'll write that as 0.01256 times 10 to the 20th power. But again, notice that our decimal is in the wrong place. Now we need to move it 2 places to the right, and that means we need to subtract 2. Since we moved it 2 to the right, subtract 2 from our exponent, and we end up with 1.256 times 10 to the 18th. And notice, you can do this on your calculator, by the way. If you go to mode, and notice in the top row, go over to Sci for scientific notation, and then we can enter 2.4, and then second, that comma, notice the EE above it, that's giving us scientific notation. So we have E negative 4. So far that tells us 2.4, and that E means times 10 to this exponent. So times 10 to the negative 4, and we're going to raise that to the negative 5th power. So raise that to the negative 5 power, and we get, notice our answer is in scientific notation, and if we rounded, 1.256 times 10 to the 18th. So it's looking good, and I hope you find that your work looks good as well. Good luck.